Good evening, everyone. I don't know if it's evening wherever you are watching this video from, but welcome to my YouTube channel. This is Ivan Okwari speaking, and I'm going to be taking you through a paper review, a machine paper review on spiking neural networks, where we are trying to predict and analyze and determine online news with data and which is being integrated with neural networks. So the whole point of this paper review, I did through, I went to the paper. It is online and it's easy accessible. And the review, I'm trying to go through the model that was used here, the metrics, the strengths and weaknesses, the thought processes that the authors went through and used when they were writing this paper, when they're going to this paper. So this research paper that I was going to address is a challenge of integrating time series data into online news with online news. So you can have stock prices and are trying to integrate that with online news like articles to create better predictive models. So in that way, we are using spiking neural networks to do this task. So our problem at hand is trying to arise with our time series. Time series data means that data changes with time. You get at this moment it can be different data, in the next 1 hour it is different data. So that is what I understand by time series data. Example, yeah, we have stock prices, as you can see. And I know with your experience of watching of dealing with stock prices, they change with time. Okay, so that is our time series data. And online news, our articles. The online news, that is really explanatory. So the problem here you're having at hand is the imbalance in data heterogeneity, which poses a challenge in creating a unified representation suitable for a single model, as well as interactability, where it's challenging to understand how combined data sources, e.g. time series and news, interact and influence the model's predictions. So, as I was still trying to say, here you're trying to focus on the stock price prediction. You know, with stock prices, we have different, if you are to go through the stock markets, we have different sources of stock prices. There's WFD, there are quite a number that I'm not so liaised with right now, but there are like 6 or 7 different ones. So we are trying to integrate these stock prices, this stock data, this stock information with our financial news, you get, so that we can predict the next stock prices, the next stock market, the data that is gonna come. Like at the beginning, we're trying to use online news to integrate it into our stock prices to predict whether we are going to have a rise or fall in our stock data. So as a result, our method that we're going to use potentially can be applied in other financial applications, where integrating time series data with online news or other textual data sources could be beneficial, such as market trend analysis, risk assessment, and portfolio optimization. So the goal is to develop a method that can continuously learn from streaming data, both in time series and news, and make predictions. Get it? So here, what we are working with is we are using a model of spiking neural networks, SNN, and as a way we are trying to get our online news and then our multiple time series data, and then integrate them together using a threshold representation encoding, okay, which is here as given as a TR encoding. So our news data is encoded with a numerical value of a -1 or a +1. We are using a 3D space architecture. As you can see, this is, if I go to my next slide, this is a 3D space architecture that shows the connection and like spiking neurons between the different data. So I'm going back just a bit, I'll keep explaining this. So there are connections between our neurons established in the small world, in our small 3D cube. Imagine a 3D cube that we have. And in each cube, there are quite on each line, we use each dot as a neuron. So let's say we have a 3 by 3 matrix of a cube. not so, oh, a 4x4 cube. Yes, a 4x4 cube with a 4x4 with four dots up and down, and it's a cube. So there are connections between each different cubes. From one neuron, I mean from between different neurons, from one neuron to the other. And as you can see here, where you see multiple lines, those are very many different connections from different neurons. You get, so where you see this line, that's why there's less connections. So our neurons are mapped in a 3D space based on their temporal similarity. So connections are made between neurons and established using a small word connectivity rule, where closer neurons are more likely to be connected than the ones which are farther. So our model learns by adjusting the connections between the neurons based on the input data and the desired output. So our input data is, let's say, our current stock price, our current stock data of today. We're trying to get that current stock data and use and combine it using our threshold-based representation encoding using with the online news to determine our output for next day's closing price of specific stock. So that's how our model is learning. We're using 50% of our data right now to determine 50% of the next data. So as you can see here, you have graphs that I got from the paper, whereby we are trying to predict the stock, our stock data, and the blue line means the predicted value, where the red line means the true value. So as you can see, we have our true line. That is the red line. That is now how our stock is in our stock data, our stock market currently. So we're trying to predict and see how our model is learning. And as you can see, it is roughly very accurate, and there's a small error. As you can see, the accuracy is quite good, and the error is different. The error is quite small. Yes, the error is quite small here. So going ahead, when we are trying to integrate this, we can do it with or without news. So the thing is, integrating online news with our stock data is quite tricky and quite very hard. But there's a way it helps that when we use news to predict in our model to predict our output for the next day's stock prices, it is better in that now if you can see via let me first sorry. Yes. Here with news, we have pentagons here that we are trying to perfectly understand our predictions with news and without news. So the blue line is with no news and the red line is with news. So explaining this further, when we try to train our model with half the data and test it with the other half, we find that the root mean square error for predicting the adjusted closing price of the stock is lower when we use news compared to when we don't. So as you can see, when we use news, the root mean error is lower than when we don't. So in this pentagon, as you can see, the closer we get to the center of the pentagon, the closer you get to the center of the pentagon, the more accurate our news is, the less the error we get. So if I'm to get an example of this first pentagon, without no news, our error is quite huge with the different stock options. These are different stock options that we have. There's wheat, there's MSFT, there's LEN, there's IBM. They're quite different, like I said at the beginning. So the pentagon is quite huge compared when we use news. Our error is quite small. So yes, and we use graphs to show how much information is being exchanged between different factors, like the high price, the low price, the news indicator. We notice that whenever news is included, there are broader connections between factors, indicating more interaction and possibly better predictions. So we ran different experiments on the stocks to see if including news improves predictive accuracy and constantly. And we find that for most stocks the most different stocks that we have available, including news to it, leads to a smaller prediction errors, which is good for making more accurate predictions. moving ahead, we are using different metrics to come up with our model. And in our model, we are having two different things called TNI and BOW. TNI input is turning news index that we are using to address this issue we have. This suggests that the TNI it's a data-driven bias mitigation that I could talk about. It suggests that researchers might be evaluating the effectiveness of TNI in reducing bias compared to other methods, potentially like metrics, like comparison of prediction accuracy without bias and mitigation techniques. So I had some notes around here that could help explain this further. Yes. So this matrix you are trying to work with is it's a time series data. So imagine you have several lines on a graph representing different things like temperature, rainfall, wind speed, which I do every day. We call each line a time series. So one of these lines, let's call it a TSO. This one we want to predict in the future. So since you're working with stock data, let's say we have stock data, and we have lines in between them, and we're trying to predict our next stock, which are calling TSO. So we have another line on the same graph, which is a TN9, but this one represents how much news talks about specific things related to data on other lines. For example, if the news talks about rainy weather, this line might go up, or when rainfall is in time, it goes up. So if there's more talk about stock increase, this line goes up, another one goes up. So you have the two different lines, the TSO and the TNI. So at every moment in time, we create a group of numbers that represents what's happening in all time series and the TNI. Each group is like a snapshot at everything at the moment. So when you're training the model, we use the snapshots in a window of time to teach a special kind of model called a spiking neural network to guess what the next value of our TSO will be next. So it's like teaching a computer to predict the future based on what's happening now and what the news is saying. So our TSO, we're using our TSO, the TNI and the snapshots to determine what our TSO will be in the coming future. So instead of using actual numbers in our snapshots, we convert them into spikes, spike trains or spikes. So each spike represents a change of data over time. Since you're working with time series data, this data can change over time. So we are converting them into spikes. So this helps the model focus on important changes and patterns in the data on the news. So heading back here, our TNI here, these are the methods we used for determining the TNI. This is now the TNI we use in the bag of words, BOW, with it has a function of bag of words, and the positive and negative, like we talked about at the beginning, a positive one and a negative one. So here, a bag of words is now like dictionary, a container of the words that are being used in online news, the words that are being said in the online news. You extract these words from the bag and we determine how much they are being said, how much they are being talked about to determine whether our stock price is going to go up, down in the coming whatever. So strengths and weaknesses. Once we use online news to integrate to come up with neurons and inspecting these neural networks, our error is quite less, like I talked about. So it helps us it allows for unified presentation of data, facilitate integration and analysis into the same framework. So using the bag of words approach provides an objective method of quantifying the impact of news on stock prices. Like we have seen, the news really impacts a lot into the stock prices, reducing reliance on subjective and quantitative analysis. And weaknesses, well, when it comes to some other stock, yes, if you are to use online news, if you are to integrate online news to this, yeah, it would help with coming up with better predictions and all, but this is not the case for every. So the case